So that's the first thing I always do. I plug in the number I'm approaching and see if I get a numeric value. Well, again, what does that mean to get a numeric value? What does it look like if I don't get one? Well, here's a for instance. In the first situation is when I get something we call an indeterminate form. So let's have a look at these two limits that we're looking to evaluate here. So in each case here, I'm going to still try step 1. I'm going to plug in -2 and see what happens. And when I do, I get 0 on top of my fraction. I get 0 on the bottom. We call this an indeterminate form. The reason why it's indeterminate is because this fraction, 0 over 0, or 0 divided by 0, causes a conflict with 3 different principles in math, okay, that would tell us that this is a different result. First off, if we take 0 and divide it by any number, that's supposed to be 0. If we take any number and divide it by itself, like we have here, 0 is being divided by itself, that's supposed to equal 1. So there's 2 answers there that, well, they're not the same thing. Lastly, if I divide by 0, I'm not allowed to do that. I mean, dividing by 0 gives me an infinitely big number. So this thing could be like approaching infinity, or negative infinity for that matter. Those are all different answers, quite different. 0, 1, and some infinitely big or infinitely small number, or infinitely negative number, I should say. Those are all different. So that's why it's an indeterminate form, because each of those answers has a rule of math that would support that. But depending on which rule of math you're looking at, you're going to get a totally different answer. So when I get this indeterminate form, that just simply means I have more work to do. And most of the time, for what you're going to be doing, it means you're going to have to factor. So the top, which is a difference of squares, would factor into x plus 2 times x minus 2. On the bottom, of course, I still have x plus 2. Notice now that the numerator and the denominator both have a quantity of x plus 2 essentially being multiplied. Down here, essentially I'm multiplying by 1. So, because I have the same quantity being multiplied on the top and the bottom, they would cancel out, which leaves me with the limit as x approaches -2 of x minus 2. That cancellation gets rid of the 0 over 0. So now once that cancellation occurs, I go back to step 1. I'm going to plug in the number that x is approaching and see if I get a numeric value. And if I do get -4. So that's the value of the limit. The limit of x squared minus 4 over x plus 2 as x approaches -2 is -4.